Alright, so we're just going to talk about linear and quadratic functions, some evaluations and fractions. We'll get to the contents in a moment, but take it easy. I tried to make it as simple as possible, but I left a few things out, so we can talk about it later. So the contents, we're going to talk about rational numbers, combining and multiplying and dividing fractions, evaluations of both linear and quadratic, and their graphs. Okay, I sort of worked that into just introductory quadratic and linear issues. So let's get started with the rational numbers. And there are two major concepts: combining, which is adding and subtracting fractions, and scaling, which is multiplication and dividing fractions. Now, in combining, you're going to need to have common denominators. The bottom numbers are the same, and we'll get into that in just a moment, but just be wary, it's a little weird. So, when we're combining, as I said before, the denominators, the bottom numbers, must be the same. You do this by finding a multiple of both the bottom numbers that evenly go into something. So we'll take a look at that in more detail, but don't worry too much. So multiplying fractions, you have to just multiply numerator to numerator and denominator to denominator. So you're multiplying straight across. Tops, you're just going to multiply, and bottoms, you're just going to multiply. And that's the easiest one to work with at the present time. But we'll get into combining now. Well, dividing. So dividing, all you have to do is multiply by the reciprocal. In this case, what we have is 1/2. So all you have to do really is to take that fraction, flip it upside down, or whichever way you want to look at it, flip it, and then multiply. So the reciprocal of 1/2 is 2/1, and I hope you can see where we got 10. Now, in examples of combining fractions, notice that in the first example, the denominators, the bottom numbers, are the same. So all I had to do was carry out the operation on top, producing 3. When you look at the bottom example, notice that 5 and 3 are different. So we're going to have to make them 15, because 15 is divisible by 3 evenly and by 5. So I hope you see where we have 2/3 being multiplied by 5/5. Now we do that because that produces in the bottom 15. In the same thing, when we do 1/5, we multiply by 3/3, producing 15 in the bottom. So I hope you see where we got 10/15 and 3/15. Another case that we have here is multiplying by 2/2, and we did that because 3 goes evenly into 6, but twice. So we have to multiply 2/3 on top and bottom by 2/2. I hope you see where we got 4/6 and the answer 5/6. So linear functions and evaluations. Well, linear functions are degree 1 polynomials. When you're evaluating, you just follow PEMDAS and carry out the operations. So with that, just remember that that stands for parentheses, exponents, multiplication, division, addition, and subtraction. So we'll get going on that in a second. So example 1, or A, we just took that -2 is x. So we just shoved or plugged in -2 for the x of the expression, and I hope you see where we got -3. In the second one, which is a little longer, but the same idea, we just plugged in 4 for p and carried out the operations. So solving equations, you're going to work reverse PEMDAS. That's essential to think about. The other big thing is that opposite sides are opposite operations. If one side says plus some number, in this case 1, then the opposite you do is -1 on the other side. Pay close attention to the operations. So in this animation, what we see is a guy just jumping up and down. Now, he jumps up 3 times and then has to reverse 3 times in order to get back to his normal position. So in this case, when we look at an equation, we're going to solve it by subtracting 1, because it says on the left-hand side +1, that's reverse PEMDAS, addition, and then multiplication. So we subtract 1 from both sides and then divide by 3. So I hope you see where we got 4/3 from. In this case, it's a much longer equation, and both sides have variables. So what I'd like you to do is just think about this as we're moving objects to the left-hand side that have x, and to the right-hand side everything that doesn't have x, and then we just combine them. Notice the factoring. So linear solutions produce lines, right? What is the four letters that make up linear? Well, it's line. Um, so inputs are x values, outputs are y values, which is the major issue here. So pay close attention to this before moving on. So the linear solution is based upon a line, and the line, or general equation of a line, is y equals mx plus b, where y is the output, x is the input, b is the y-intercept. That's where you're going to begin from, and m is the slope and how you're going to move. So the linear solutions, as I just pointed out, is you begin with the y-intercept to graph, and then you move accordingly to the slope. So if the slope is 3/2, you're going to move up 3 into the right, what did I say, 5? I think I said 3/5. Um, and the y-intercept will where you begin. Let's just take a closer look at an example. So here we have an example that y equals 3/2 x plus 1. So what that means is you're going to notice the slope 3/2 and the y-intercept at plus 1. So that means that you're going to begin, right, b, y-intercept, at plus 1. And then you're going to move accordingly to the 3/2. Here is an example of what we did. We started at plus 1, we went up 3, and then we went over 2. And you'll notice that we're exactly back on the line. This is essential. If you are not back on the line, it's not a correct slope. So with given that, let's move on and take a look at another process. So simplifying linear functions. This is kind of easy when you think about it. And I make sure that you pay close attention to this, because positive and negative numbers are really the operations. If you have any questions on this, we'll talk about that later. So graphing linear functions that are not like the given formula, you just make them like the given formula. So you'll notice what we did was we took 3 and multiplied it by x and 1, producing 3x plus 3. Now, then all we had to do is combine them. You can see that we have a positive 3x and a negative 5x, and that gave us negative 2x. And here's an example. Pay close attention to the way the slope behaves. It's not increasing as well as x's increase, y's are not increasing. It's actually decreasing. So as x's increase, going up, the y, as you can see, are going down or decreasing. This is a negative slope as opposed to our positive. So introduction to quadratics, they're degree 2 polynomials. They produce a picture that is a parabola. That's just the graph name. So they have two things. They can go up or down, and if they go up, they produce a minimum value, and if they go down, they produce a maximum value. I'm going to leave you to think about this when graphing. So the big things that you have to carry about, there are many ways to actually solve quadratic equations. I only go over the quadratic formula really here and a basic example a little later that you'll see. We can talk about this in person or on Google Plus if you'd like. So keep that in mind. So the general equation for a quadratic is ax squared plus bx plus c. And you usually set that to equal 0. It may not be given. And the quadratic formula gives x-intercepts. Now that's where the graph crosses the x-axis, which means the y's are 0. Okay? So keep that in mind. So a is the leading coefficient. It can never be 0. Now there's a reason why, but can you think about it? It's actually given in the beginning section here. So if a is positive, you're going to go up, and that will produce a minimum. If it's down in negative, then you're going to produce a maximum. So the important parts are all points solved will have a value for x and y component as 0. There will usually be 2 points, but there could be none or 1 as well. So you could have 0, 1, or 2 solutions for solving a quadratic. So keep that in mind. Just remember square roots. Okay? So using the quadratic formula, you're going to make sure the quadratic is given in the ax squared plus bx plus c equals 0. Identify the a, b, c components, plug them into that formula, and you'll simplify. So basically plug and play. And let's take a look at an example of using this formula. So here we have the quadratic 2x squared plus 3x minus 1. And all I did was plugged in the b, which is 3, into both sections where b was indicating, the a and the c as well. So you can see where we plug those in if you look back at the quadratic formula. And we produce these answers right here, okay? Which are not complete answers. We're going to go a little bit further. Notice that there's a positive and a negative solution. That's because the square root of any number gives a plus or minus. Like the square root of 4 is plus 2 or minus 2, because plus 2 squared is 4 and negative 2 squared is 4. So if you look at our answer here, you can see that we have both answers 0.281 and the other one negative 1.781. Now look where they cross the graph. That's important to actually focus on. So solving a basic equation, as we did here, you solve it just the same way as a linear, except that now you have a degree 2, which means you have to worry about a square root, because the opposite of squaring a number is taking the square root. Now remember, as I said before, the square root of 4 is really plus 2 or negative 2 because of what we spoke before. Now here are some sample problems to work on. Take your time and see if you can get them. Now I left a few issues in here that I wanted you to figure out, that come in that weren't particularly in the lecture. Now you'll notice that K here under 3 is very challenging, okay? So I'd like you to try to graph that as in number 4 states. So you could graph certain ones, but it's very imperative that you figure out something about that. And with that, we're going to conclude, and bye.